if you want to follow along on GitHub, I have this presentation. It's a show-off presentation, so the slides are also up there. So if you want to see the latest slide stuff, and I can pretend you're not tweeting and not paying attention to me, and you're just following my slides. So that's the link to the show-off if you want to follow along at home. Yeah. So, all right. This is a talk called Designing Hypermedia APIs. First of all, hello everybody. I'm Steve. Thank you for coming to this awesome RailsConf. First thing in the morning, it's bright and early, and there was a pre-party last night, so I appreciate waking up at 10:30 a.m., which is always difficult. If you don't know me and what I do, primarily I hack on Hackety Hack, which is originally created by Why the Lucky Stiff to teach programming to kids and other people via Ruby. So I try very hard to not make it just for kids, to make it anybody to be able to learn how to program. So that's fun. I also teach classes with Jumpstart Lab, so all teaching all the time. So if your team needs to get better at Ruby and or Rails, give us a call. We run the best training classes on earth. We're doing the Hungry Academy program with Living Social right now, so that's pretty awesome, taking people who have never been developers before and turning them into professional developers at Living Social. So it's pretty cool. Anyway, this talk is sort of about a journey that I went on. In sort of the spirit of a Native American spirit trip, right? Or whatever our conception of that is, the not real one, but the idea of one. So I sort of went wandering into the desert to find myself, and then came back, totally disgusting, not having showered. And I'm like, guys, I saw the answer out there in the desert, and I have to share it with all of you. And you're like, yeah, sure, Steve, whatever. I sort of have this continuous idea, a personal ethic of always learning. So I always like to be learning new things, if they're programming related or not programming related. And whenever I hear someone say something, whenever I hear someone that I respect or that I know knows a lot about a topic, and they say something and I don't understand what they're saying, or I think they're wrong, I always make a mental note, Coda Hale is not stupid, but he thinks that Rails is bad. Someday I should figure out why he thinks that. Because I respect Coda's opinion. And so this happened with REST one time. I heard a lot of people who knew what they were talking about say, Rails' idea of REST is not actually REST. And so I was like, that's kind of weird. I wonder why they think that. And so eventually, when I'm bored sometimes, I will be like, what is on the list of things that I don't know about yet? Let me go look into that, see why they would have that opinion, or see what they meant when they said that this is the truth. And so one day I decided to do that for REST, and I said, holy crap, Rails REST is not actually real REST. And so then, I'm a really big fan of Lean as a methodology for startups and for projects, and so I decided to essentially Lean startup a book. I said, okay, everyone, I have learned why Rails is not actually REST, so I'm gonna write a book about it, and it's not written yet. Here's an email form where you can put in your name, and I'll email you when it's ready. And I did that to see if my laptop would fall asleep. I did that to see if anybody cared other than me, right? Because the last thing that I want to do is spend a ton of time, come on. The last thing I want to do is spend a ton of time writing something and then have no one care, right? So I decided to see, cool, does anyone else care about this topic? And it turns out that a lot of you did. So I spent the next 8 months of my life researching to really make sure I knew my stuff, because the last thing that you want to do is tell everyone you're an expert and then not be an expert, right? So I spent a bunch of time reading everything there is relating to REST, and this presentation is sort of a small synthesis of what I've learned, and then this book that I'm writing, book sort of thing, is the bigger synthesis of what I've learned. And we'll talk about that later. So the first thing that I want to say is that REST is over. If you've seen this Portlandia sketch, it actually has a much deeper meaning. If you think about what happens in the sketch with what I'm saying, it's actually a pretty deep reference. But basically, if you're trying to convince someone to change their opinion, the last thing that you want to do is tell them they're stupid, right? So if you are aggressive with people, they're not going to change their opinion. They're going to dig in and fight back. So if I say hey, you guys don't actually know what REST is because you're stupid, your first reaction is to say, Steve, you suck. You don't know what you're talking about. And it's not a productive way to change people's opinions. Secondarily, REST is kind of bad branding. Does anyone know why it's representational state transfer? Exactly, right? It totally is meaningless. And this is not Roy Fielding's fault, whose dissertation defined what it is to be RESTful. When you write academic papers, you are not concerned about marketability, right? Like Roy just wants to go do his stuff and he doesn't care. And so it's sort of not his fault that this buzzword is essentially totally meaningless. And so in that sort of spirit, since no one knows what it actually means and everyone uses it wrong, rather than try to fight over the term REST and be like, this is the right REST, it's much more productive to invent yet another buzzword. So that's sort of what the people, the Restafarians, who really care about what REST means, a certain group of us have decided that it's not worth that battle, it's not going to be productive, and no one is going to care. So as far as I'm concerned, Rails does REST perfectly. So in the rest of this talk, when I say REST, I will be meaning Rails' idea of REST, not the real idea of REST. And so that's sort of, yeah, to move forward and have a productive discussion. This also doesn't mean that this is bad. So like, you know, what DHH said earlier today, right? Like people said that Rails REST was useless wankery, and now we all consider it the default. And I would totally rather work with a Rails-ish REST API than SOAP or all the other like really crappy APIs we had before. Like it is fundamentally a good thing, but I think that we can do better, right? So in that sort of spirit of like not resting on our laurels, if we really want to move forward with really large applications and really awesome APIs, like I think that we can do better than we're doing currently. And so this is a talk about how to move forward from the sort of standard APIs that we all know and use today to something that's better. So instead of REST APIs, we're going to talk about hypermedia APIs. And so this communicates much more effectively what I'm actually talking about. If you know what hypermedia is. So basically, hypermedia is the idea you have media, or the older school was text, so hypertext. You have this text document or other form of media, and then you add links to it. That's the hyper part. So it's hyper is the prefix meaning like above or beyond. So this is beyond just regular text. There are links that connect things together. So fundamentally, hypermedia APIs are about transferring text documents or other kinds of media that have links to connect them to the rest of the world. Hypermedia APIs. And there's sort of a reason that we talk about why this matters and why it's important. It's also a really good name because it points out the fundamentally thing that's wrong with the way that, or I should stop saying wrong even, like what's different about it than the Rails idea of things. Like how many of you return links in your JSON representations to other stuff in your APIs, right? You don't. So this is like the fundamental difference. Maybe, okay, some of you do. This, like some people, yeah, who have heard me talk before, like, of course I do now that I listen to you. But we don't do this. So this is the like fundamental difference in what I'm talking about versus what we do today is these links. And so why should you bother, right? Let's like, before even talking about the details, let's talk about why you should care about what I have to say. So basically, hypermedia designs scale better, they're more easily changed, and they promote decoupling and encapsulation with all of the software engineering benefits that those things bring. I really, really liked, again, to reference DHH's talk earlier today, which I don't 100% agree with, but I really agreed with parts of it. So one of the things that he sort of alluded to is that we as developers are really good at saying things like, I love change, I love decoupling, I love encapsulation. And then we do attr accessor, attr accessor, attr accessor, and we make these huge classes that go on for miles, right? Like if you ask anyone, like, do you write code that is very tightly coupled? You'll say, of course not. When Don Knuth made the idea of literate programming, he said that one of the reasons he liked the name literate programming is that it implicitly implied that everyone else's programs were illiterate. So unfortunately, like Roy Fielding actually said, like APIs today have an X-rated level of coupling going on. Like we have incredibly tight coupling between the clients and the server, and you feel that pain all the time. You just don't know that it's painful and that you can do better. So this is like radically decoupling things. Now the negatives, this is not like any architectural choice. There are pros and there are cons, and sometimes those cons matter, and so this is not a universally good way of building things. The downside mostly comes down to latency. So if you need something to happen in microseconds, then REST is not for you, or hypermedia APIs are not for you. Caches are one way that these APIs scale, and as the joke goes, there are two hard problems in computer science: naming things, cache invalidation, and off by one errors. So like cache invalidation is really freaking hard, and it's difficult to get right, and so that's an inherently difficult problem. Also, since it tends to be textual, or these APIs are sent via text, they won't be as efficient on an individual level as like a binary protocol. So if you compare JSON to BSON, for example, like BSON is much smaller because it's this custom binary representation of what was textual. And there are advantages to the text, but it means that it's much bigger to transfer stuff. And usually that doesn't matter, but sometimes it does. So like if that matters to you, then this may not be the appropriate thing to do. So keep these cons in mind. Roy Fielding has this really great quote that I enjoy quite a bit. Rest is software design on the scale of decades. Every detail is intended to promote software longevity and independent evolution. Many of the constraints are directly opposed to short-term efficiency. Unfortunately, people are fairly good at short-term design and really awful at long-term design. And this is just, I really don't like appeals to human nature. I think that human nature is kind of like not true in a lot of ways, but it's very natural for people to be thinking in the short term, right? Like, I am wearing these Vibrams right now, for example. I go to the gym like once or twice a month, right? Because like I'm like, I need to go running, right? There's a 5K at RailsConf, but then I like need to play StarCraft, or like something comes up and I don't go to the gym, right? And I know that like for my long-term health, if I run, I will be more healthy in the long term, but that's like far away, that's tomorrow, right? So, you know, my mother would say that like getting tattoos and like earrings and like, you know, hair and stuff, like that's gonna hurt you in the long term. And I'm not thinking about that. So people just in general do this, right? So we need to release this weekend. Screw if the software is good or not. That release is going out on Friday because we have a deadline. And so we tend to do this a lot. We sort of make short-term decisions that come back to bite us later, right? Like every time I write code that doesn't have tests behind it, I'm like, yeah, I know how to write code without tests. And then 6 months later, I'm like, why did I not write any tests? So, you know, it happens. So these are the two big things that are like a big deal, longevity and independent evolution. That's the true benefit, and that's what I see that we fail at today with our APIs currently, right? You release a new version of your API, all the old stuff breaks, or you force people to upgrade. We have this like churn, things don't go for a long time. Like we could be building software on the scale of decades. Like HTML has survived for like 30 years now, right? Like the World Wide Web is the largest information system that we've ever built as humanity, which is kind of crazy. And yeah, in general, like coupling is the enemy. This is sort of a personal theme I've been on lately with like testing via mocks and like a bunch of other things, but like software coupling is the true enemy of being able to change your software quickly and easily, which is one of my favorite metrics on code quality, right? Like if you can change your code easily, it's good code. Coupling is the enemy of all of that. I guess actually, before I start talking about this, I'm gonna go back for a second to this longevity and independent evolution bit. And that thing, like the web is the largest information system that we have ever built. It is humanity's crowning achievement as far as I'm concerned. Like the web is awesome, right? But it's also really, really massive. So in 2010, Google was the largest single entity on the web. And Google has like 3 blessed languages, right? They allow you to use Java, they allow you to use C++, and they allow you to use Python. In the last couple of years, they've actually started discouraging the use of Python because Python cannot handle Google scale. And that's not really a knock on Python. I mean, Ruby is not on that list at all, right? But like, Google accounted for 8% of web traffic in 2010. So if only 2 languages are efficient enough to handle something that is 1 to 2 orders of magnitude smaller than the web in general, right? Like that's scale, like web scale. It's really unfortunate that web scale became a meme, is because like web scale is truly a thing. Like the World Wide Web is incomprehensibly large and it works, right? The fact that I'm like on the internet right now and so are you, and you're like beaming the signal over there to that router and then it's going like somewhere else and then back instantly it's totally magic, right? And we all know as programmers that all of our software is crappy, right? So like all of the ricketiness of these things built on top of each other, like it's intense. So anyway, the point is that most of these things need to happen to handle a decentralized web that's made up of a ton of different entities that all work together, right? Like all of us work for, well, I mean, everybody here works for Groupon or Living Social, right? But if you don't, like the other people that exist somewhere outside of that, like have to cooperate to make the web work. And so these kinds of design choices are really important to handle this massively decoupled huge information network. Anyway, so there are 2 rules of what makes a Hypermedia API. One of the problems with REST is that its proponents have been actively hostile to explaining what it really means and why you should care. So I made it simple. 2 things. You use HTTP properly with an asterisk, and then you use Hypermedia to guide clients through your business process. The asterisk is there because technically you don't have to use HTTP. You can use any protocol you want, but in reality you should use HTTP. And the reason is that my slides don't advance. There we go. This is the constraints that define REST in Roy Fielding's dissertation. What is up here does not really matter. The important part is that if you use HTTP properly, you get all of these checked off except for that sub-constraint on the uniform interface constraint. Everything else, it works. Like those all exist by just following web standards and using HTTP and URI and all those other things the way they were meant to be used. There are a couple small exceptions, but we're going to gloss over that because this is a 45-minute talk. But rule number 2, the Hypermedia to guide your clients through the business process part, that is the one constraint here that does not exist. So use HTTP properly, and then guide people through your business process. We're going to spend the rest of this talk discussing this last little tiny bullet point, because it's the hard one. It's the one that can't be handled by standards bodies. You have to actually do it yourself, and that's the reason why HTTP does not give it to you, is because it's about the content of the messages you send over the wire, and that really is not standard in the same way. Like, it's not a protocol level concern, it's an application level concern. So that's all it takes. Use links, use HTTP correctly. This is not using HTTP correctly, even though it is, right? So like, this is a valid HTTP request that will work, but it violates certain semantics that can't be covered by the standard, right? Like we can say in the standard that something should happen that way, but just because the computer makes it work the right way does not mean it is following the intention of the standards. This is what I mean by properly, right? Like, this is a valid HTTP request. It's just not a semantically valid HTTP request. And we're past that with Rails, but when I talk to people who are not Ruby developers, sometimes they're not on this boat yet. So anyway, so now we're going to talk about 5 steps to actually build an API in this manner. And these are sort of rough guidelines. This is also talking entirely about the server. If we have some time at the end, usually this talk is half an hour and I have 45 minutes, so we might spend a little bit of time talking about client stuff at the end, but we're going to talk mostly about server-side things today, because this is RailsConf. We're building servers, not clients. That's for the JavaScript people. Which are not us, of course. Anyway, so these are the 5 steps to doing a server. You evaluate your business processes, you create a state machine that represents them, you use that state machine to evaluate your media type needs, you create or use existing media types, and then you implement it with the magical hand wavy, then build it, right? So you notice there's nothing about URLs, there's nothing about objects, there's nothing about routes, so these things are totally irrelevant. And let's talk about all these things. A wild example appears. One of the other things about this topic is that it's really abstract. So I like to always, when I'm looking at something that's about web standards, I'm reading something, and I have this general rule, I try to think of a concrete example and then apply the abstract idea to that example to see how it works. So you'll often hear people talk about like web browsers as the perfect API client. And REST people tend to do this all the time. And they're like, HTML and a web browser are like perfect. And they're the exact way that things work. So if you want to read Roy Fielding's dissertation, it's really abstract and it's really difficult in the terminology if you're not familiar with it. But that's how you have to do is think about the concrete example and how that abstract idea applies to the concrete example. So we're going to build an API for an example service to explain this abstract idea in these steps. So if you don't know about Mendicant University, it's a really cool project by Greg Brown to help intermediate Ruby developers become awesome Ruby developers. And one of their students built this service called W3C Love. Basically, it wraps the W3C HTML validator. So if you've ever used that before, which hopefully you do, it only lets you put in one web page at a time. But I have a website with tons of pages, right? And that's super lame to type them in every single time. So we wrote this gem called W3C Love that lets you submit a website. It crawls your site, validates all the pages, and gives you a report back on if they've passed the validator or not. It's super cool. I've been meaning to make a integration test that does this sometime, which would be really neat, right? Before deploy, make sure your pages are valid. Anyway. So this is what it looks like today. And when Jamie came to me and said, or Jaime came to me and said, hey, what should I do with this API? This sort of looks like what you would imagine like if you were building an API to do this, this is what I think that you would build as well. So basically, to check a website, you submit a GET request to this URL, and you pass in a GET parameter with the URI of the site that you want to check, and then it returns you a bunch of JSON, and it gives you this like, was it successful in scraping? How many pages did it look at? How many errors were there? Which is like 1 million, because we don't ever think about these things. And like individual ones for every page and how many errors and what they were, right? Big giant mess of JSON. There's also this web pages service, which basically gives you one page. So if the first thing crawls, this gives you the link to one of them. And it's there, first of all, for convenience, because if you're going to use the gem to validate multiple pages, you probably want to do one page. And because it needs to be built to build the multi-page crawler, right? So the multi-page thing uses this to do it. So he exposed it as well. So it's the second process. And it gives you the same like big pile of JSON that this does. So that is we need to now think about this service, and I've sort of talked about it already, but we need to evaluate our business process, step one. What does our API actually do, right? Like what software are we building? One of the things I love about test-driven development is that it forces me to actually confront what I'm building rather than just screwing around with software, right? Like I can not think about what I should be doing and just run random code all day. So there's these two fundamental processes we need to handle. We have this web pages API and the sitemaps API. Individual pages, whole sites. So those are the two processes we need to handle. Then we make a state machine out of the steps in that business process. I love the dot language for making state machines. You can write text files and it spits out these beautiful graphs. This is a little teeny small. Let's see if we can, yeah, there we go. Does this scroll? It does not scroll. I'll shrink it again. So basically, this is sort of like how I built a random state machine to do this process. So we need to be able to make a request to actually get the data back, right? So that's the second half. But we need that variable, the actual URL that we're checking. So we need to template that somehow. So we need an intermediate step, a form, to say, hey, put in the URL and hit process, and then it will actually do the processing. So there's sort of two steps. So the request form and the request form both hit the middle ones. They do the processing and give you this display, which is the same in both instances, and it returns you back to the root. To demonstrate a little more that this is actually a like two-step process, I made an alternate version of the state machine, which has more states that show that you have these two discrete processes. And this is also an incredibly simple process, right? Because we have, again, 45 minutes. So if you had something where it's like, post this to a URL, poll it continually until it says it's done processing, go hit this other one, like it might be more complicated. The example people always use is ordering a cup of coffee from Starbucks, right? So you like get the menu, read what the menu is, put in your order, it redirects you to a place where you poll to see if your coffee is done, and then make another post to get your coffee. So like that would be a more complicated state machine. This one's simple because we have a simple talk. So from that state machine, we shrink the slides back down again. And we need to now evaluate our media type needs. Unfortunately, JSON cannot drive a Hypermedia API. I'm sorry about this. I love JSON too, but there's good news. And the good news is that you can build Hypermedia semantics on top of JSON and use JSON, the serialization format, to build your API. So you don't have to use XML. And in fact, XML suffers the same thing. Essentially, JSON and XML are semantically void of anything. They just show you how to serialize some data, right? So what's the standard way to make a link in JSON, right? You can't. There's no standard for that. So you can build formats on top of these things and still use your beloved JSON. Like when people say you can't use JSON to drive an API, they mean you can't use application JSON, not a custom format built on top of JSON. So that's what we're going to do, is build a format on top of JSON. Now, there's a little word here. There's a tension that goes on between using types that already exist and building your own type. Ideally, you should use a type that already exists, and you can look up. There's tons of types. There's actually two fantastic Hypermedia JSON types. One is named collection plus JSON, and the other one is named HAL. But so if everyone makes their own individual type, then we haven't gained anything because you still need to use the same tools, like individual tools on every service. But if we all used one type, it would be really hard to shoebox all of those things into one idea. So the idea is this healthy middle ground where we have a number of types that do different semantic things, but we share them among similar applications so we can all benefit from sharing the tooling, but not so much that it like loses all meaning or only has super specific meaning. There's a healthy medium. We're going to talk about building a custom type, just so I can show you what that process is. But ideally, you would say like collection plus JSON would actually work perfectly here. So we could say, cool, we're not designing anything. We're going to use collection plus JSON. We're done. So we're going to create a type. Media type design is very much an art as well as a science. There's actually lots of things to consider, and it's a very complicated topic, and there's no right or wrong answers. You kind of have to try it. We got really lucky that the people that invented all this stuff way back when, like the guys who invented SGML and HTML, sort of ended up accidentally doing the right thing. The idea that like Tim Berners-Lee is this magical superhuman who magically invented everything perfect is totally wrong, and if you don't know anything about the history, if you think that's true, HTML was very much a happy accident of people who liked, Mark Anderson said something one time about like HTML was created by SGML nerds and people who liked angle brackets. So it just happened to be a very happy accident that we stumbled across this like way of building things. And that's actually what Fielding did with his dissertation, was codify stuff that had existed previously. Like we did tons of development and then codified it into, this is what has worked for us in the past. So that's actually what people say, like REST is wankery. Like REST is encoding what we've already done and been successful at building. So anyway, there's lots of awesome books and stuff you can read about this topic, so we're gonna not go into it too in detail, but show you some of the things. You basically need to consider two large things when designing a media type. You need to worry about the data that you're gonna transfer, and you need to worry about the hypermedia controls that do the linking back and forth. So we're gonna build a type called w3clove.validation plus JSON. And its media type designation would look like this: application/vnd.w3clove.validation plus JSON. If you've never dealt with media types before, basically you can break them into two parts. There's like a category, which is the application part. So like HTML is text/HTML, application/JSON, image/ping. So it's like a broad category. And then the second half is the details. So the plus JSON on the end means, hey, if you don't understand the semantics, you can process this as JSON and it will still work. Like we're adding semantics on top, plus JSON. The VND dot W3C love is a vendor prefix. So when we're building a specific type just for us for now, we do the VND dot and then our organization name to show that it's namespaced under our organization. And then if other people wanted to build validation services, we would work with them to build a validation plus JSON that would work across our companies. But for now, since it's specific, there's a vendor tree. So VND.W3Clove.validation plus JSON, which is a mouthful. Eventually, this would be standard, hopefully. Once it years and years of people using this awesome media type, eventually it would come down to application/validation, and that would be a type. But that takes a long time and lots of people working together, and that's sort of how the standards process works, which is incredibly fascinating if you've never looked into it. You are web developers, you should know how web stuff works, like in general, right? Like there's a governing body that controls what goes into browsers, that controls what you are able to build. So if you don't know how that works, put that on your mental list of like stuff to learn someday, because it does affect you indirectly, and you have the power to change it. That's a whole nother talk. So we're going to need all these data elements from our JSON before, right? We're going to need to know like when it was scraped, if it was successful, what information comes back. So we need to address those elements. And so in our media type definition, we want to include some language like this. A response may contain created at, scraping address, blah, 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 all these things. And we would say, here's the stuff I'm going to give you. Here are the attributes. There's actually one of the art things about media type design is you can either say, here is a list of keys and values with data and the things that are being returned, or you can get really specific. There are pros and cons to each approach. This is a specific approach where we say what all of the details are. And then hypermedia controls, which are like links and forms and all the ways we connect our representations together. So when we looked at our thing, we knew we needed a link to actually go from the form. We needed a form to template the URL, and then we needed a way to make that form point somewhere to show where that processing was happening. So we'll say that a response can make a forms element, which has an array of JSON objects. They have href, rel, and data elements. Data has keys and values that are name and value. And so this is how we build a form. This is sort of a little abstract. It'll make more sense when I show you an example in a second. Then we also want to name like link relations. So any form that has the sitemap form link relation will give you a sitemap API request. Any sitemap link will process that form and give you the information about it. And now we need to build it. Magic step 5. So this is where it gets more concrete even. So we went back and talked about stuff a little bit abstract. Here's the details of like concrete stuff. So imagine we wrapped our web stuff so that we could make a request to a URL and provide a media type. So hit the root of the service. It would return you in an example, the thing that would return is this, which is a valid W3C love plus validation plus JSON response, which has 2 links. So it's a JSON array that shows you, hey, if you want to process a website, then go here. If you want to process a sitemap request, go here. And you'll notice that I did the ... because the href doesn't matter. What the URLs are is totally irrelevant in this case. So what we would do is we'd make our client process this forms, and it would go through, this is some like pseudocode, well not really pseudocode, but sort of pseudocode, where it would grab the links out of the response and then find the first one where the rel mapped sitemap form and grab the href attribute out of it, right? So we have this list, we want to grab the href attribute of the one with the rel attribute that we're looking for. And then we make another request to that URI. We follow the link. This is the exact same way that you interact with a web site, right? Like go to google.com, click on a button, click on a link, do whatever. And then we make a request there. And that returns another form, or that returns a thing with a forms element. And that form says there's an href here, it is a sitemap form, and we need a check and then a value, so you have to fill in a value. So our client would look at this form, process it, say, cool, I need a value. That would be the URL that we're going to actually look at. And then it would say, I need to submit this as a GET request to the href that exists on this form. So then it would do that, and we would get our data back, which would basically look the same thing as that big giant pile of data. In the end, we'd be able to display that information to the user because we'd have those semantics. So that's an example of this response. To recap the server-side stuff, you evaluate your business processes, you create a state machine that represents those processes. And this is really useful if you don't even care about this API stuff or you think that I'm full of crap. Doing that is really, really useful to understanding how your service works. Like checking out what things go where and what steps people need to take is super awesome. There's always that story about every time Amazon took a chunk off of their sign-up process, they saw business increase, right? Like think about when you fill out a form on the web, right? If it's like steps 1 of 7, you're like, I'm not using this website at all. And it's the same thing with APIs. So examining your website as a state machine can help you understand like, oh, to order something on my website takes 30 clicks. No wonder we're not making any money, right? And optimizing those things can help. So it's useful even if you don't do this API stuff. But then you can look at that state machine and see what kinds of things you need in your media type, and then you can pick a media type that exists or build your own, and then implement it on the server side. And that's it. Ta-da! Now, this talk in general is about getting you vaguely familiar with this terminology and sort of understanding what I'm talking about. This is a really deep topic. Like I said, I devoted 8 months of my life reading books and like learning stuff and talking to people. It's hard. It's not simple. And it's basically impossible for me to explain in half an hour all of the details and make sure you really understand it. So I am writing that book, which is called DesigningHypermediaAPIs.com. It's not actually a book. It's a website where I post updates that are like article-sized things, because again, with that lean thing, I was like, wait, I'm going to lean a book by spending 6 months writing big chunks of it? That's stupid. So we have a forum that's free where you can like talk about these topics and get questions and stuff. It's really cool. This is the end of the slides, but I still have another 12 minutes, so I'm going to talk about some client stuff and show you some code on the client side since we've been talking about server stuff. But yeah, that's me on Twitter, my website, the website for the book, and one of the really awesome things that we're doing at Jumpstart, to do that for a brief second, is all of our curriculum is free online. And we actually like have it on, it's just an Octopress install that you can actually submit updates to. So I've been really enjoying like having people go through our lessons that aren't even taking Hungry Academy or don't pay us to come teach them. You can come check out the stuff we do teach and submit pull requests, and then I will merge them in, which is awesome. So that's really cool, and I enjoy it a lot. So check out the stuff on at tutorials.jumpstartlab.com. It's pretty awesome. All right, so let's pull up a client. There is a media type for microblogging, Someone made one. Mike Amundsen, who's an awesome dude. He made a type for microblogging. So he has a server implementation that's written in Node, but we won't talk about that. And it exposes a Hypermedia API to do microblogging stuff. So as an example, I thought I would show you a client. I use the Mac Twitter client, which is terrible, but it's the best thing we have, and it looks like this, right? And so I figured, I'll build one that looks just like that for this Hypermedia API. So because I maintain shoes, I wrote it in shoes, and I'm going to show you what it looks like. It's very ugly and very straightforward and doesn't have really error processing because it's an example, toy app. But basically, you can type in a username and type in a password, password or whatever. And then it allows you to change the URL. So you could use this with any service that complies with this and click save. And if my internet works, which it says it's working, but we'll see if this actually happens or not. Churning, churning, churning. Since it's on Heroku, it takes time to spin up the instance. Anyway, you'll see an interface that sort of looks a little bit like the sample Twitter application. So you got your little box where you can post stuff. It shows all the messages that exist right now. It's just a list. So this is like a sample desktop client that's totally driven by Hypermedia. So how this works is I talk really loud into my microphone. Basically, we require OStruct because it's really useful for configuration stuff. And then I write little wrappers around net HTTP because its interface is horrible. Then we grab some configuration data and we store the root URL that we're going to use. And you can actually go check this out. It gives you XHTML if you ask for it. And so you can actually view this over there. But we save this default URL, and this is the only URL in the whole thing entirely. This is sort of slightly complicated because Shoes uses the idea of URLs to map pages of interface. So basically there are two screens, the preference screen and then the index. And those are done by these two methods. And the index, we fetch the data at the current URI that we're looking at. And then if we don't have a username and password set, we redirect to the preferences screen because authenticating, this uses HTTP basic authentication. And so asking for that on every request is stupid. So we save it off into some configuration stuff. So if we have that configuration already, what we do is we take the current data that was returned, and we use, in my case, XPath to search. Can you guys see this? Should I make this bigger? This is smaller. I don't know. I'll do it a little bit. So we look to see if there's a form with a certain class on it. So like if there's the ability at the current time to post a message, there'll be a form with this attribute on it. So if we find it, then we say what's happening, and we render the box where you can type in what text it is. And when you push the post button, it grabs the action attribute of that form, which has the URL in it, and then sends a post with our username and password and the message text to that URL. Done. Super simple. And then it redirects you back to the main page, refreshes the interface, basically. So that's like posting a new update. And then if there's a list of messages in the current response, it finds that certain div with those IDs and the UL, because this is based on XHTML as opposed to on JSON. And then it displays all messages. It goes through each list element, and it displays that message text and the user text. And that's how we get all of these individual things, right? Like this is a list with the tweet text and the person who said it. Tons of testing tweets on there, which is fun. And so that's it. And then there's a little refresh button down here. So, and then there's crap for the preferences screen, which you don't really need to see. So what's interesting about this is that the interface is totally driven by the response that's returned from the server. So if we didn't include the list of messages, that list just wouldn't appear in the interface. If we didn't include the ability to post messages, that would just disappear from the interface. And so we can actually change the way that our clients work by changing the way our server works. And this is really powerful for pushing updates, right? Like this is a desktop app, but it has that really nice property about the web where you get to push updates to users instantaneously. And it's because we've decoupled the logic of what the business process is. Instead of like having a gem that works on the server and works on the client where we duplicate our logic, we have all our logic on the server, and the client knows how to show the endpoints of that logic and perform this process, but it doesn't worry about the internal details of like, what does updating a message actually mean? How does that work? It doesn't know, it just submits links and forms. This is like one of the worst. I don't hate Node, I don't like Node, but one of the worst examples I've ever heard of people saying that you can use Node is like why it's a good idea is like, oh, but you can duplicate your models on the client side and the server side since it's both in JavaScript. And I'm like, that's the same thing as copying and pasting your models into one file into another. Like you're using 2 bits of code, like you're using the same model in 2 places. That's wrong. You should have a canonical source, and clients should be clients and servers should be servers. Which is another rant. But basically, like, you can see how this is an interface that's not a web browser that's being driven by the response from the server. If we wanted to have more things, there's a lot more to the spec. So like, for example, we could actually make the user links clickable and then display a user page, like that exists. The ability to sign up through the service, like that all exists. I just didn't want to build out everything. But you can see how these 2 interface elements would appear or disappear based on what the server returns. So like, if we had an overload from the server, say we get a fail whale, right? Rather than having a box that fails to post the message, we could actually not display the box at all. Like if you turned off the post a message response part of what your API is returning, the box to post a message would just disappear. And maybe we'd leave a message saying like, the server is overloaded instead. And then our clients would just like not let you. I freaking hate how the Twitter client, like, if it doesn't go through, it just pops up a message that's like, yo, I couldn't post that stuff. And it leaves it sit there, right? Like, if I can't post something, don't give me the ability to post something. Because it's always like 45 seconds later, which is like a year in Twitter time. And so it's terrible. But like, we could handle these situations in different ways, is what I'm trying to say. And it's server driven, and the client reacts to the way that the server is implemented, which allows us to do all kinds of cool things. So yeah, so this is an application of like building a desktop client as opposed to a web client. There's also the same strategy applies. So if you go see Yehuda's talk later, for example, he's going to talk about the future of Rails and how like using Rails to serve JSON to drive client-side apps is like really cool. And that's another example. Like you can essentially build a client-side application that's all JavaScript that reads from your API and then makes your interface happen based on what it is. It's sort of very Inception because you're building a client on the clients, and this, it's like all inside this framework, which is weird, but it's the same basic idea, and it's really freaking cool. So that is one nice thing is about the future of all that stuff. And so I think we're converging to these things in different ways, I guess. So anyway, I'm out of time, so I hope I've piqued your interest. If you want to learn more, you can read the mailing list, you can buy my junk, you can come talk to me later, I'll be around. I have this mohawk, everyone thinks I'm Skrillex, so like it's easy to find me. I was in Austin for 2 hours and someone yelled at a car like, Skrillex! And I was like, oh God, it's a mohawk. But it happens. So yeah, thanks for coming and listening, and enjoy the rest of your RailsConf.